Hey Mitch, how you doing?
Good. How are you?
Doing all right, man?
I have like two little bugs in my code, I think, but it's very close to replicating exactly.
Hmm. Oh, that's great. It's I know that the macro the folks who use the quant is it quantecon.org? I mean, there's a whole group of macroeconomists. Julia, I know they have packages for polynomial approximations that they use. I haven't really dug into that.
Yeah, so far I'm just duplicating your Chebyshev stuff.
Hmm.
Um, yeah, I'm gonna bet a lot of what they do is more specific than it needs to be.
Hmm.
Like I haven't seen economists using jump all that frequently, which is very strange.
Yeah.
Because I mean, I'll show you the code for what I have. Like that looks identical.
Yeah. It's what I'd love to do is I've been working on, well, I haven't had a chance to work on it in a while, but there's using the MCP formulation that Chang and Rutherford did in terms of getting it to solve instead of iteratively, but as a one-shot MCP problem, which is actually much more efficient. Um, uh, but the part that I'm trying to deal with is approximating the derivatives of the value function, because that's the nice
Oh,
thing about that approach, is that you can get not only the value function but also its derivatives, which allows you to impose curvature conditions, which is for what they call shape preserving um, dynamic
yeah.
programming, which is ideal. Make sure that you have the proper concavity in your objective,
Wait.
or vice
What?
or convexity as the need may be. But
Hold on, I think I just broke my stuff. Well, let me let me try a couple things here. I'll share my screen in a second. Oh, Shelly's here.
hey Shelly,
Hey everybody, how's it going?
doing pretty good. How are you?
I'm good, hanging in there. How are you, my friend?
Doing all right. Doing all right. Just keeping busy. We got a little project going on with UN Economic Commission for Africa, so that's keeping me busy for the moment.
Oh,
But
good, good, good.
yeah, yeah. How's ERS?
Oh, shenanigans, shenanigans. I'm sure everyone has told you.
Yeah, we'll do a separate call on that one.
Yeah, yeah. A friend sent me a little meme. It was like, if you let them shenan once, they will shenanigan, and and it's just so silly. How are you, Midge?
Oh, I'm doing all right. I just restarted my code and now it doesn't give me the same answers as it just was.
Oh
Oh,
no.
I know. I, I figured out why. I didn't save a file. That was stupid. Okay. I should share my screen to show you what I'm tapping through.
Oh, thank you.
Okay, let me zoom this in just a smidgen. Okay. So I'm not going to tell you anything yet, but I'm going to show you this. These numbers here are fairly, oh no, they are exactly the same as these numbers here.
Mm-hmm. Yep, surrounding. Yep.
Good news, I don't have a bug anymore.
Okay.
Um, and you can see the coefficients here are the same as the coefficients here.
Yeah.
Up to a little bit. They're not perfect, but they're pretty close.
Yeah.
That's going to be solver or something. Okay, so the question is what am I doing? I haven't shared any code with anybody yet because I'm going to do that during this meeting because people have wanted to. You guys have asked about GitHub and VS Code, so I'm just going to put this thing on GitHub just during this session because it's not very hard. Would that be useful to do at the beginning or near the end? In other words, would you like to see the code now or follow along with this?
In terms of explaining how what you're building for, you want to show I mean, I don't know, because I
Yeah,
know what code you're dealing with, but it's up to Shelly. What would be useful for you, because you haven't.
yeah. This was written by
Yeah, I
C1.
apologize. I've been gone so long. Maybe you guys can tell me where you're at, and then
let
do
me
whatever you want to do.
pull this open. So the first thing, so basically what we have here, we have a Ramsey macro growth model solved within this framework. Let me open this. So this might help you a little bit. Basically, we're going to solve this problem right here. That's the idea. So we have a GAMS version on the right, and that is directly behind. There we go. I have a GAMS version on the right and the Julia version on the left. And I've set this up so that when it is on GitHub, you can clone it and just hit Shift Enter on each line. So that's all I'm doing when I run things. You see a little check mark. And it will just do whatever you need it to do. It'll install the packages. Everything will be hunky-dory. Okay, let me scroll here a little bit. Here, Siwa has defined I. Here, I've defined I. Actually, let me do one thing real quick. I just hit Alt-J and then R, and what that does is it restarts my Julia terminal. So that way, I'll just let all of this run. So you see it's activating my project. It's checking to see that the packages are installed. Hopefully they are because I've been running my code. Okay, now I don't need that. Okay, so he's got I. He's got a certain number of iterations, which I defined later. Julia has pi built in. I don't need tests. Delta, that's the same. CEIS. So I'm just copy, pasted, essentially. Okay, if I scroll down to here, so now they're going to define some Chebyshev polynomials. So there's some polynomial approximation stuff going on. So arg and arg. This is like a little Julia thing. It does the same thing. The @ dot just tells it to vectorize each operation.
Okay.
Same with this little cosine dot. It just takes cosine of each thing in that vector.
Mm-hmm.
And I should be running this stuff because then I can point at it for you. Yeah, so there it is. Here is arg, and here's x. This is just the cosine of each of these values.
Yeah.
And to hide my terminal in VS Code, I'm hitting Control and then the back tick or the tilde, and it opens and closes my terminal. And then you define a matrix. This phi bar, that's just a matrix of, I can just show you. It's just this matrix. What is it? It's like it's representing the Chebyshev polynomials, right?
Yeah, the actual terms of the actual, yeah, the what they call the basis functions for the
Yep.
polynomial. Yeah.
Yep. So I've done that. Julia is, most programming languages are row based. Julia happens to be column based. So I just defined the transpose and then transposed it to get the original.
Oh, okay.
Yeah, nothing too horrible there. The double semicolon means go to the next column. A single semicolon means go to the next, like, it means append the row. So a double one, it means append a column.
Mm.
Okay, ST is the same. It's the state variables. Okay. Now I scroll. I'm going to initialize my model. You called it VF estimate. I've called it the same thing.
Mm-hmm.
So let's see here. We've got two parameters, capital and the coefficients of A. I declare mine as an explicit parameter because that way I can update it within the model.
Okay.
And then my variables. So here and here. No, here and here. Look at the variables, not the equations. Variables. Julia lets me just define the bounds implicitly when declaring them and the start values. These ones are a little bit more complicated. I might write a function to do that for me later, but this is just setting the start values. It's the same as what is going on right here.
Okay.
So it's I greater than or equal to 3. That's what this is doing. And again, I might write a function to make this be better. Because it'd be better if it were up here and it was just like phi start values or something. And then I set my objective here. You set it farther down. Nothing too terrible. The definitions of all the equations should look familiar, or all the constraints.
Mm-hmm.
Instead of equals E equals, it's equals equals.
Okay.
It's pretty much the main difference. But I like it because it looks like if you look at this equation and this equation, it's the same.
Yeah.
Big difference, not case sensitive, very case sensitive.
Yeah.
I don't need to see the printing, so I just set my model to silent. Hold on, I gotta make sure that I'm actually running this stuff. So the Julia, the first time you run something, it takes a while. So this is just compiling a bunch of stuff. There it is. If I run it again, it's instant. So that just initializes my model, make it so it doesn't print anything. And then, yeah, here you're setting up for it to find the A values, right? In this block right here. So
Yeah,
you're doing a loop. Sorry, go for it.
No, yeah, no, go ahead. I think, yeah.
Yeah, you're doing a loop that you're going to kill once the test value is bigger than delta or less than delta. So you're only going to run when test is bigger than delta.
Mm-hmm.
That's the check I'm doing right here. So I just do that down below and then I break the loop. Yeah. So it starts here. And then you're looping over I. I'm doing the exact same thing for I and I. This loop, you set the capital, solve it, and then store a value, store the objective value.
Yeah.
Same thing. And then let's see here. And then you're just storing the old value and finding the error. So that's what's going on here.
Yeah, I'm regressing to get the new. I'm regressing
Yep.
to get the new parameters, and then testing the deviation between the previous and the new estimate. Yeah.
Yep. Cool. So that runs through. Everything's hunky dory. And then if I scroll, and then you have your actual simulation.
Mm-hmm.
So you redefine a model called simulation. It's the same model, so I just use the same model.
Yeah.
Yeah. Yeah, and then there we go. And the big difference is that mine, so let me go up to here. I'm going to redefine the model, find my coefficients, and run my objective, run my simulation, and it's done. And I have a report. And there's the report. So this one has different numbers than this does because I was experimenting with different simulation values.
Out of curiosity, did it converge to the same Chebyshev coefficients in the same number of iterations, more or less?
The same coefficients, yes. After I switched this to be IPOPT or IPOPT instead of what it was using, yes, it gets the same A's. I didn't check the iterations. I could. Actually,
Just out of curiosity, I was just out of curiosity. In 101, I see.
Yeah.
Okay.
So this is a direct translation of this. Yep. And I'll check that in a second as well. The problem with doing a direct translation is that it makes a lot of global variables, and Julia doesn't like global variables. So it slows things down a little bit.
Is it because it's in terms of how it uses memory, or?
It's because those values can change because they're just like the compiler doesn't necessarily know what they are before evaluation, and it sort of makes the state space bigger, so it has to look for more things. But I have a fix for it. Okay, I'm going to restart my Julia. And just give it a second. There it is. Okay. So I have a new file, main.jl.
Mm-hmm.
The top is exactly the same. Maybe I'm using linear algebra now and I wasn't using it before. I'll show you the model functions in a second. So because I'm using linear algebra, I can't use I because I stands for the identity matrix.
I see.
So I've just changed it to Chebyshev terms.
Okay.
And there's 4. This now encapsulates all of the data. So it's all of, it's all of this data with the exception of the discount factor. You don't need to type in the discount factor, but it's still created. Come on, AI. So it's a struct, and this is like a generated thing. So it just figures out what it is, does that calculation. And then I take my data. I have to tell it I is the Chebyshev terms, and I have to tell it what the initial A values are. So it makes my model. I won't set it to silent. We'll see what it does. Okay. Now it's going to solve. It's going to take a second because compiling. And it's going to print a lot of stuff because I didn't set it to silent. That's why I set it to silent usually. But when it does finish, so it returns 2 things. It returns the A coefficients and the error terms, which is what Siwa is returning here as well somewhere. Way down, way down here.
Yeah.
Error is important. So I just save it the same way. Do you ever regret not setting the silent to be true?
Yeah, there's a
Hey, oh. Wow. I wonder how many times it's going to solve.
well, you said it took 101, right? Or
Yeah, that was with different initial conditions, though.
I see. Oh yeah, if you set it to the action what you converge to, then it should just take 1 iteration.
Yeah.
Yeah. That's usually why I say I save once I've run it one time and I actually get the values. At least even if I change some parameters, it'll still be not too far, and so it'll save time.
What I'm going to do first is I'm going to set silent and then rerun this, and it's going to take like no time at all.
Oh,
I think
okay.
the majority of the time is just printing to the terminal.
I see. Yeah.
I think that's true in GAMS too. So I think if you just turned off printing altogether, it would run much faster. Oh, I hate this. Why is it taking so long?
Yeah, in GAMS there's also that thing where you can there's also a solver option where it keeps sort of the solver spooled up so it doesn't have to solve, then write the solution, and then restart the solve. It just sort of does that. But I tend to use it a lot for
solve link maybe.
Yes, yeah. Solve link is the older too.
Right here.
Yeah.
Come on, let's go, Julia. I decided just to restart because I got sick of waiting.
Yeah.
Because it takes like a millisecond. Come on. Sometimes Julia likes to hang out for a second. Ugh. Yeah, the budget thing has me a little stressed out. I'm sure Shelly's the same. Yeah.
Yeah, we have no budget, no money.
No money.
But you mean for fiscal 2026?
Oh, for 26. Yeah, I'm not sure.
That Congress gave the what was pretty much, well, maybe minus a million or so, but I thought it was pretty much intact.
So it seems like we have to approve everything, even what we were given.
Yeah.
So like for the food security report, it's usually green light. It's been done for 31 years.
Right.
And that is not happening.
Oh boy, no wonder Spiro's retiring.
Yeah. So I'm not sure what will happen in 2026. But yeah, no, I was excited to be at ERS to, work with Mitch on some of these stuff, but we don't have any money for
Yeah.
co-op agreements. I don't know. Maybe we'll find out more.
Yeah. Oh, so I restarted the code and turned the set silent on, and it solved very quickly.
Oh, okay.
Do the forward simulation. Just verify that the values are not like that. And then let's look at the, oops, hey. There it is. So there's our solution.
Yep. And
How do you turn?
I'm sorry.
How do you turn the solver output off completely? Do you know?
In GAMS, well,
because here we have 2, which doesn't write it to the listing file.
yes.
Is it like 0 to not write it at all?
Oh boy.
I forget.
Erwin Kalbagen would be a person to add to the.
Let's find out. Because if I do that, it should run much faster.
It looks like that's what Google says.
It's still printing though.
Yeah,
Remove the solution listing following solves. I guess.
Yeah. I saw when it said equals off, which didn't help. Ooh, this is putting in the listing file too. That's fun. Yeah, I always test the Google AI with like math questions.
Oh, really? Oh, wow.
Yeah. Because a couple of years ago, you could ask it to prove that an even number plus an even number is odd, and it would do it.
Oh, no. That's not good for what, the middle schoolers?
That's like a discrete question. Yeah. It's a college student thing. Because you can prove that even plus even is even.
Well, I guess, yeah, I was thinking just, young people asking it to
do 2 plus 2.
Yeah.
No, I come from I did a lot of teaching, like at the college level. So we'd ask them to prove things, and a lot of students would just turn in AI.
Oh, wow.
Yeah. It's actually very funny because math has been dealing with that issue for ages. Because like Wolfram Alpha can solve any like basic math problem.
Right. Mathematics. Yeah.
And then at the first part of COVID, we were largely dismissed for our concerns about what we like. They used to get like 4 cheating things a year, and then suddenly it went to like 400, and they're all from math.
Oh, wow.
But AI has caught up, and now the humanities care.
Yeah.
Oh, this is taking forever. Oh no. Yeah. So you see, it's taking about as long as it took the first time. But when it does solve, it's going to get the same answer as the Julia stuff, which is good.
Yeah.
So while this is running, I can run different simulations here. Oh, what I also did, I wanted to see what would happen if I just didn't change the Chebyshev numbers just for testing to make sure that it was doing something.
Yeah.
Oh, and I've joined it together. Because I had a bug. Why is it taking so long to do a join? It's weird. I had a bug where, so this is 0 values. That's why there's a 0. And this is changing A. Oh, let me run this again just so it's a little prettier. 0 values, changing A. And I was getting a problem where this number was the exact same as this number, which shouldn't happen. So I knew I had a bug. And in fact, now I should wait because if I do it, then it's going to break it. Come on. Yeah. Yeah, GAMS is running a lot slower, in particular because of the prints.
Yeah.
But I think it's close. Wow, goes fast.
Yeah, now it's doing the simulation stage.
Yeah. Which is going to take 100 iterations.
Right.
That's not too bad.
Oh,
Oh, I think it's done.
yeah.
I always get these warnings that it cannot delete directory because I have a cloud backup service running.
Right. I had the same thing. When I started using OneDrive, I started getting those errors a lot.
Yep.
Yeah.
This over here. Close this and this. Go back to here. Look at DFA. So numbers are the same, and the A's are the same, which is cool.
Yeah.
Oops. And what was it?
Let me see. I think the second one's not quite the same, but it's close. Yeah, they're pretty close.
Yeah, these are close, but they're a little bit off, which is interesting. The simulation values come out to be the same, which is good. Oh yeah, and I should show you the model functions. So I've set this up to be relatively intelligent. So if you're in Julia, and oops, no. Hold on. What did I do? There we go. If you're in Julia, you can access the help menu just by typing a question mark, and it'll say help. And you can type any function, and it will give you whatever is above here. Usually that's the help documentation. So I've just typed up what it's doing so you can see in case you get confused. But you can see how the discount factor is created. So I have phi bar 1 is actually the transpose.
Yeah.
Because that's what it is. And then when I actually use it, get rid of this. Right. Oh, no, I don't use it in here at all. So this is my model. Shouldn't be surprising at all. It's the same exact thing, just copied and pasted. When I compute A, I just do that as a actual matrix operation.
Oh, phi bar 1. Right. Okay. Yep.
Yeah. Because it's the sum of these multiplied. So this little dot times means take that, or take value, multiply it by the rows, and then add up, I think it's the columns, and then divide. Cool. And I'm printing the number of iterations so I can see that very easily. And I can do a forward simulation as well. But the real nice thing, let me just bring this down. You can do this in GAMS as well. But I can change to 10 terms. This one takes a little bit longer because there's 10 of them. See what it says at the end.
Okay.
It might be taking even longer because I'm recording and stuff. There it goes. Cool. Did it not print out? It may not have. Yep. And then that's with 10 term approximations, which is different, but it's interesting. Cool. So I should upload this to GitHub so you guys can actually use it. So let's see here. Okay. So here's the power of VS Code. VS Code is a Microsoft product. GitHub's a Microsoft product. So these two things play very nicely with each other. Do I have a Git extension? Nope. So Git is installed by default. If it says install, I don't have it. If it doesn't, then I do. I don't think Shelly's allowed to use Copilot. So sorry.
It's. I think some people can request. I think there's a pilot happening.
That's right.
A Copilot?
Yeah.
Yeah, they're doing a beta test at that for ERS,
Yeah.
or USDA actually. Yeah.
It's real nice. Yeah, for some things. Other times it's like a little kid yelling suggestions at you while you're typing. Like, go away. I don't think you need any special extensions for this. I have one that I'll show you. But I click this little thing that looks like a branch. It's called source control. I haven't done anything with Git yet. This is what you'd see in an empty directory. So I opened up, I'm gonna delete these two just so they're gone. Like I just opened a folder here and started typing. Go to source and go to initialize, and that's it. So I've just initialized the Git repo, but I don't want everything in there. Like I don't want the listing files, right?
Yeah.
I don't want the GDXs. So what you do is make a git ignore, but I always forget what the git ignore is. So what I did is I hit Control-Shift-P, open that little prompt. I can add git ignore. This is the extension. And I want a Julia git ignore. And I think, do they have one for GAMS? They might not. Nope. So that means I need to go into my git ignore. Click this. I do want to share the manifest because I want to fix the things.
Mm-hmm.
I'm going to get rid of star.gdx. Come on. It should update automatically to, you'll see them disappear. Like you'll see this updates and now it's gone.
Mm-hmm.
That's pretty nice.
It is very nice. You can also over here see how it's sort of grayed out.
Yeah.
That's also telling me that it's not included in my Git repo. I think everything else is fine. Oh, I don't need XLSX. So I don't need that one. I do want to share the docx. The reason that I am sharing the manifest, so the way Julia works, I'll just show this off. There's a project.2ml file, but this doesn't, the way it's set up, it doesn't tell me anything about package versions. So if in like 6 months you're like, oh, I'll use this, but they've updated jump and something breaks, unlikely. The manifest tells it, no, you're going to take these specific versions.
Mm-hmm.
So usually you don't share the manifest, but this time I'm going to. Okay, I think that's it. Initial commit. I'll hit this plus to just stage everything. I could do them one at a time, but it's the initial one. Hit commit, and that's it. Publish branch. The one downside about GitHub in VS Code is I can't publish to a specific group. So like we have the WiNDC group and the MPSGE group. So I have to publish this on my personal one. Oops. And I'll have to change that name because I've just called it dynamic RAM. So just click the button. But now it should be this one. And there it is. See, just now. I think if I refresh, it'll say, it still says now. That's a shame. Yeah, literally just now. I'll throw this into a chat. Shelly may not be able to see it, but I'll get it to you.
Oh, thank you.
Yeah. Yeah. So all you have to do is clone it, which I can do. Oh, here, watch this. Okay, I'm just going to open a new VS Code with Control-Shift-N. It's just a brand new VS Code. Clone repository. And okay. Thank you, Teams. Teams was directly in front of where I needed to type. I'm going to do clone from GitHub. I'm going to type Mitch Phillipson. Dynamic Ramsey, that's it. This isn't coming up because it's my account. This is coming up because I typed Mitch Phillipson in dynamic.
Mm-hmm.
And I can click that. It'll ask me where I want to put it. I'm going to put it in the stupid spot on the desktop in a folder called temp. So remember to delete it. And would I like to open it? Yes, I would. There it is. Then you could immediately click this And as long as you have Julia installed, oh, there it goes. It just takes a second for VS Code to figure out it's a Julia file. It'll just run. So you can see the exact thing that I've been doing. It should just run, which is cool. And then let me, yeah. So going back to this one, if I made a change in main, like I don't need to print this. Immediately you can see the change pop up here. So I deleted a couple lines. It immediately popped up that there was a change.
Mhm.
If I click that, it tells me where the change is. The red means I deleted. It's very nice. And I can type here, comment, the green means it was added. It's very slick. I like it quite a bit. Yeah. Let's see here. I want to get rid of that one. But then all I have to do is stage it. I could have more changes than this, but this is just the one file. Oh, I hit Control Enter there, and that did that, and then sync. Dokie. And now those changes are on GitHub. Yeah, it's one of those things where it makes your life much easier. Let's see here. Did this finish? Oh yeah, I did a while ago. All right. So what else do you want to talk about? Or what else do you want to know? What else do you want to hear about?
This is great. So, I'm gonna, yeah, I mean, maybe I'm gonna work on, I mean, actually the MCP version, I think, maybe I actually, what I don't have working yet is the shape preserving part of it, but in terms of converting it into, so that it solves for, Chebyshev polynomial at the same time that it's solving the actual, optimization problem at the same time, is much more efficient than having to sort of iterate, sort of
Right.
especially solve it to convergence. Yeah, that actually might be a nice one to another example to do. But let me get that. I'll send you that version, and then maybe we can look at that one too, because then I think you get a lot of computational efficiency, especially if you can get the curvature thing to work correctly.
Yeah. I mean, I think you can really speed up your code if we are able to, I've closed it. Which one is it here? This one. You'll really speed up your code if you're able to just suppress the models completely.
Yeah.
Like if you're able to figure out what that value is, like maybe 3, I don't know. I looked it up and it wasn't, the documentation wasn't super clear.
Yeah.
Which is unfortunate. Yeah, but then I bet it would run pretty fast. Like, how big of calculations are you thinking about doing? Like, how many iterations?
Well, usually for a one-state problem, it doesn't usually take that many iterations. Sometimes when you get to more than one state variable, and then you're then actually you sort of have so you have two Chebyshev polynomials sort of for and so the dimensionality starts to creep in a little bit, sort of the cursive dimensionality. But yeah, usually you don't need to, if you've chosen your parameters such that there's reasonable concavity, you don't usually need a lot of iterations to get to convergence. That's usually not the big constraint.
There is one thing I could do. So I did is I just opened the package manager by hitting the bracket, the right bracket, and I'm adding Plotly. Plotly is just a plotting package. Yeah, I realized I should actually plot these things down what they look like, huh? Oops, that's 14. That's not what I wanted. I've also, there we go, done something kind of special. Yeah. So I've set Julia up. It automatically just uses 4 of my CPUs, which is kind of cool. So it makes things run a little bit faster.
Yeah.
Okay, so what I want to do, Plotly.js. I always get syntax. Plot DFA. Yeah, do you want to see capital or consumption or investment?
Yeah, I mean, I know investment would be great.
See what it looks like. I always forget the syntax for plotting. The one package that I learned for plotting, which was Plotly, is the one that takes the longest to plot the first time because it's using a lot of stuff in the back end. There it is. So capital starts high and it fades down pretty quick. So I could also do, let me look at DFA. Because I want to see all the lines at once, right?
Yeah.
So here's some data frame stuff. How are you two with data frames?
Preferred as an R user.
Okay, good. So I'm gonna unstack this data. Or I guess is it stacking? I think I'm gonna stack this data.
Mm-hmm.
And I'm gonna stack not time. Hey, that worked. I think it's variable name equals arm or param. Okay, cool. What I just did there make sense? So
You just
I just took
reshaped
it
it,
from,
right?
yeah, I just reshaped it.
Mm.
And that's gonna allow me to plot DF. Oh, okay. AI filled it in for me. All right. That's why I like AI. Because I forget the syntax and it just helps. So there's all of them on the same plot.
Yeah.
So it levels out pretty quick at about 22 iterations. So maybe we should throw in a check that says if it stabilizes or something. Because this hits a steady state.
Yeah, and I didn't actually go back to see how this compared to, although he transformed his objective, but it still should come to the same steady state more or less. The Tom's original, the MPSG Ramsey.
Yeah, this is pretty slick. I enjoy it. And yeah, so you just play around with the values and it just changes sort of dynamically. And
you can do that? Sorry, I missed.
All I did was change this number right here.
Oh, okay.
Like a 2.
Mm-hmm.
And then I just run through everything.
Oh, gotcha.
And I could set this up, like it'd be smarter to set this up as a function that just spit out the plots. Anything in Julia that you put into a function is going to run faster. Because the compiler, it can do fancy stuff with the compiler, which is good. Yeah, graphs are fun. These just sort of go down. I can see what happens if I give it 10 terms. Don't need this down here. Doesn't hurt anything, but don't need it. The compute A coefficients obviously takes a little longer because there's more terms. Oh, but it's done. Oh, it's weird. Yeah. So at this point, it's just sort of data management and making it look pretty. Because I think the standard thing to do is export to Excel, then make like a pivot table and make the graphs from there.
Yeah.
Same thing.
Yeah.
Yeah, same thing, just a different process.
Yeah, I have a feeling that with the using the structure of Julia, like when you have a two-state problem or multi-state problem, it could be more than two state variables, which means that you have to iterate over sort of that whole combination of I and j. So
Yeah.
if you have i's 4 dimensions, then you have and if you put the same number of Chebyshev polynomials on each state variable, then you sort of running over 16 different 16 different grid points that you have to sort of evaluate. So it's there'll be a lot of efficiencies to having that within the Julia framework.
Yes, Julia's. In fact, I might even set that up differently so there's no loop at all. I could. I don't know how that would work. I have to think about that one.
Mm-hmm.
Yeah, Julia's very fast on loops, which is very nice.
Yeah.
One fairly nice thing about this graph here is, so this is some documentation I've written for MPSGE, but in the actual thing is one of those graphs, and it's fully. Oops. Okay, I've broken it. It's fully interactive in the web page. This is just a very small example, but it goes right to the web. It's very nice. Ooh, I get homework help. Thanks, Google. All right. I've been meaning to look at this for a while, C1. I'm just
no, I'm glad
for other things.
No problem. Actually, I would have finished sort of pushed a little bit on the documentation. I've been sort of doing some other stuff recently, but I would have finished sort of the write-up. Because the nice thing, obviously you can see most of the heavy lifting is in terms of sort of approximating the polynomial, the sort of the value of these polynomials. And if, in a simple enough function, in a simple enough problem, you actually know the exact functional form of the value function, and so you can actually compare how the approximation does to the actual true value function, and it doesn't do terribly, but but I've been trying to sort of work on Tom's approach to sort of see if I can get a better. And obviously, if you actually were able to enforce some of the curvature conditions as well, you'd be more assured of getting closer to the actual. So
yeah.
But at least you don't have to do all the work of trying to you don't have to set the terminal conditions, because when you find the value function, then it will. That's kind of it should converge to the steady state without you having to try to approximate it.
Very useful thing.
Yeah. That's cool. Well, thanks for taking the time. But maybe I'll look for a two-state one. I have and see in terms of if computationally how it compares when you try and do it in Julia.
And oh, and Shelley, one place you can find, if you go to the WiNDC website, resources, seminars, WiNDC Weekly, is why I upload all the stuff. I have to upload Eli's recording as well.
Oh, thank you.
This will update to have a little link to the GitHub.
Oh, great. Thank you.
Yeah.
I will let Ron know about this too, because he has to take home and get the dog.
Yep. Yep. Cool.
Yeah.
Yep.
Well,
so I'll get this updated with the GitHub.
Okay.
Because I had missed so many meetings, I did have a question. So yeah, I'm kind of in a different situation than most people. I don't do modeling full time, so always for my career, half my career has been more topical with econometrics. So like I would call myself like a very light modeler, the ultimate lightness. But now people like Siwa who are so skilled. Ron is probably getting sick of ERS. As people are disappearing, I didn't know, is there any like vision for MPSG and Julia to maybe be for the light user? So the thing I appreciate about, GAMS is that I can code because I'm doing so many different things. If I don't code, I don't have a record, and that's why I do not like Genpack. And so I was just wondering, kind of given what you're doing and your new vision, because I missed all those on front end.
Yeah, I mean that's the goal, because like for the casual modeler, I think MPSGE is incredibly useful because you can add taxes and it's just, you don't have to worry about all the repercussions. And I mean, looking at GAMS versus Julia is going to be a lot easier to use. It's a lot more like R, like the data frames. And, but yeah, that's my goal.
Okay, and so I guess not say the bulk of your work, but a large effort is going to continue to kind of move GAM products or into Julia. Oh, great, thank you.
And I'm gonna maintain the GAMS stuff. I might simplify the GAMS stuff a little bit, but I think throwing out the GAMS stuff would be nice.
Oh yeah, of course, yeah. You know, some people are hardcore GAMS, but yeah, also the trouble we're having here is justifying software purchases.
Yep.
So our worry is that
that's the big win for Julia.
Yeah.
Has the FED group been thinking about maybe moving out of something besides GAMS?
No, but it seems like we had a modelers meeting a couple weeks ago, and we were told that really all software contracts don't get approved at the last minute. So like all the SaaS users, they don't really approve SaaS until the day before the contract's supposed to expire. And it's not like GAMS where you can continue to use GAMS without an updated license. SaaS will disappear.
Yeah.
So we're just trying to figure out, if ERS will be here long term, what will we do when they get more strict with certain softwares?
Yep. Yep. Julia, that's open source, man.
Oh, perfect. Thank you. Yeah, no, yeah, to me, just trying to map out like the next 5 years of my career, if all the modelers leave. Oh, yeah. Okay, maybe we just need a career commiseration meeting on top of it.
Yeah, I think that's an October 1st kind of meeting.
Okay.
But I really hope that's resolved in terms of the money situation. Because maybe it's because there's an extra layer of Doge, right, that has to be gotten through, right, to get stuff done.
Yeah, but it seems like all things, not even just like tech things anymore. Yeah, so the SaaS thing, and I didn't realize the SaaS, whatever ERS is SaaS license, is not even an annual license. It's every 3 months. So it's like a panic mode every 3 months. And we use SaaS for the household food security survey. So
Yeah. Just like knowing, I'm sure the bureaucracy is worse than it is at like a university level, but having a contract that expires every 3 months at the university level would be annoying. Oh my goodness.
yeah, and I don't know why, so it's not like ERS is the only SaaS user across USDA or the federal government. So yeah. But thank you, Mitch. Yeah, I was just curious, on how to keep some of the work going, knowing there may be some continued volatility. But yeah, no, I would say, at least from my perspective, I do have strong interest in continuing to participate. It was just a rough 6 months.
Tell me about it. Yeah. Hopefully it gets better, but yeah, no, I feel you. I really do.
Oh no, yeah, all you can do is apologize. They said AAEA. Everyone asked about co-op agreements, and they're like, they have not told us anything. We have not heard anything.
Yep, that's fine.
Oh boy. Well, hang in there.
Oh, you guys too. Yeah, no, I feel like we're all in the same boat. It's just research and science right now.
Yeah. The good news is that because all like WiNDC has funding for at least through the end of the year.
Oh, great.
Mhm.
So I have a little bit of time. EPA wants to give us more.
Oh, good.
I have to do something for Canada, I think. But yeah, I'm gonna try to survive, hang on as long as I can, and see what happens.
Oh, good. I feel like that's all we can do, huh? Maybe we'll get
Yeah.
more stability in the next fiscal year.
Yeah. I'm
Well, thank you guys.
yeah, no, thank you, Shelley. Anytime.
I appreciate all the hard work, and Mitch. I'm gonna clone your repository and work on it.
Yeah.
Give it a spin.
Yeah. And if Shelley, if you ever want a transition from R to Julia and you want pointers, just let me know.
Oh, okay. Yeah, so I still teach stats for IU, and I was thinking about that this week. I was like, oh, I wonder if I showed them something in Julia. And I was like, oh, they'd probably go tell the dean on me. Yeah. But maybe I'll get there. Because it's just,
I mean,
it's just as
data's
valuable.
data.
Yeah, yeah, I think so. But I don't know, maybe because you're dealing with a higher caliber of math student and I'm dealing with public affairs students, they're very scared of anything math related or anything coding. And so I've had students tell me I talked to some old timer in the office and they told me all they really need to know is Excel and they'll be fine in their careers. So I say, oh.
Their
Not for
career is
long.
what? I don't know.
Yeah, yeah, that's the thing, huh?
Yeah, no.
So
Yeah,
yeah,
Microsoft's
Julie would
already
be
built.
very interesting.
Microsoft's already put AI in Excel. If all they know is Excel, they're going to be in a lot of trouble because AI will just do it.
Yeah, that is very true. Maybe I should tell them that. But so for Julia and R, I guess, are you just running R and using VS
Yeah, you can
Code
do R and
as R
VS Code.
Studio? Okay.
Yeah.
Okay.
And VS or R Studio is actually pretty nice for R.
Yeah,
But
yeah, that's why
I
I
do it.
didn't make a transition. But Julia will do all of the things that R and R Studio as a combo do.
Yeah.
Okay. Oh wow.
Yeah.
Yeah, add it
I'll
to my
talk to you
list
about
of
teaching.
Hmm?
I'll talk to you about teaching sometime.
Oh yeah, yeah,
I love
yeah.
teaching.
Oh really? Oh, do you have a cheating assignment with the new position?
No, staff are not allowed to teach.
Oh really?
Oh, really?
Yeah. Well, yeah, because if staff did research and taught, what's the point of faculty?
Yeah.
Oh, but that may be the case come fiscal year 2026.
I know, right? But no, I taught for 6, 7 years at St. Edward's University in Austin.
Oh, wonderful.
I was on a 4-4.
Oh, gee whiz. Teaching math, all math 4-4. Oh, goodness.
That was a lot. It was a lot.
Oh, yeah, we have to talk about teaching sometime. Yeah, no, I love
Yeah.
some of your tips about incorporating AI.
Yes.
I do
If you have
allow it.
if you have students that are afraid of coding, AI is they can vibe code most of it and they can get like focus on the logic.
Oh, great. Yeah, I would love some tips for that.
Yeah, it went really well.
Oh, good. That's
Yeah.
good to hear. And nobody panicked about cheating and academic dishonesty and all the things.
They were master students, so
Okay, yeah, I only teach master's level students. Luckily, IU never made me like my whole history with them, and now I just teach first year master's stats.
yeah, that'd be great. I love talking about teaching.
Oh, good.
Love it.
Yeah. I thought I hated it when I was in academia, and then they asked me to continue to teach, and I was like, oh, maybe I don't hate it.
Yeah, 4 classes is a lot though.
Yeah, maybe it's the time burden when you're actually doing it more heavily.
Yeah, 4 classes, working probably 60 hours a week for liberal arts university professor wage was a bad combo.
Oh no, but it's so
Bad
impressive.
combo.
Like you have your PhD in math, you must be, killing it in life.
Yeah, I have a big house in the middle of nowhere.
Oh, good.
Actually,
American dream.
Let's see. It really is.
Oh, very nice. What are you growing?
So all the ones right above the patio there are peppers.
Oh, great.
And there's grapevines right behind
Oh, very nice.
the trellis. Ugh. I have to go harvest grapes, and then I have a problem of grapes. No.
All right,
that's
y'all.
wonderful.
Have a good one. Good to see y'all. We'll
Yeah,
catch up.
same
All
here.
right.
See you
Yeah,
soon.
thanks for coming.
Bye-bye.
Okay.